I don't know if I can. There we go. Somebody did it for me. Thank you. Okay, I'll advance to the next slide. I'm assuming everybody sees my screen okay. Can I get a nod from the presenters? Okay, perfect. Okay, so Carbon Leadership Forum, the Toronto chapter, uh, our aim is about inspiring and spurring collective action to solve the embodied carbon challenge. A lot of our presentations and events are geared towards that. Also want to have a land acknowledgement as a Toronto-based group. We acknowledge that the land we are meeting on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, and the Chippewa, and the Haudenosaunee, and the Wendat people, and is now home to many diverse First Nations, Inuit, and Métis people. We also acknowledge that Toronto is covered by Treaty 13 with the Mississauga of the Credit. Housekeeping items. If you have any questions, please do write them in the chat. We will have the Q&A period at the very end of the presentation. We recommend that you use your speaker view. Certainly do make certain that your audio and video are off. And just to note that the session is being recorded, and we will be able to post this session later on to our CLF Toronto account. So if you ever want to watch previous sessions or want to rewatch this one, you're welcome to visit our CLF account. So today's presentation is about the Ontario Embodied Carbon Awards. Our very first was held in 2023 in November. And our mission through launching these awards is to inspire, celebrate, and foster community around the discussion of embodied carbon and certainly encourage reductions. The award categories that we had in 2023, it was quite challenging because it was the first time that we launched this award. We followed suit and learned from the Vancouver Awards and created our own categories of new construction for residential, new construction for ICI, major retrofits, as well as a catch-all category we called innovation and industry. And it could remain the same. Categories could change. I know we're adding at least, I believe, one more category. However, the steering committee is currently meeting about it and finalizing the dates for this year's awards. So stay tuned, and we will definitely announce more details at the part 2 presentation in May for the 2023 awards. Our first presentation, as I mentioned, is going to be the City of Toronto's Toronto Green Standards Embodied Carbon Caps. Second presentation will be the 25 St. Clair Avenue East, the winner for the major retrofits. I will let them each, of course, kind of highlight what their projects are about. So I'll skip through these slides. You can skim over who participated in each project up on the screen. And part 2 is coming up on May 7th. Be sure to register. It will be another lunchtime presentation, and it will cover the new construction residential category as well as the ICI category. Also, if you're looking to get involved, you can certainly email us, info@clf.com. We're always looking for people to help volunteer at events, get involved with the newsletters, kind of share information with the steering committee, and even take on some research or oversee some research. Do email us, and we'd be happy to find a way to have you involved. Without further ado, I'm actually going to be passing it on to the first presenters from the City of Toronto. I'll stop sharing and I'll let you take over, Lisa.
Okay, thanks very much for having us. We're really excited to be here and really excited to have received this award. This is a partnership. Our work on embodied carbon is a partnership between the City Planning Division and the Environment Climate Division at the City of Toronto. My name is Lisa King. I'm with the City Planning Division, and I lead the Toronto Green Standard. And my partner here, do you want to introduce yourself, Zach?
Yes, hi everyone. My name is Zach Zandona. I'm a project lead with the Environment and Climate Division's New Development Unit. And like Lisa said, our groups work very closely together. My group helps mainly with the implementation of the Toronto Green Standards energy emissions and embodied carbon emissions. So yeah, happy to be here and thanks for having me.
And thank you, Zach, for also putting in the nomination for this award. Much appreciated.
Pleasure.
So just a little bit of context, and we'll just give you some highlights here of the work that we're doing. So I think many know that we have an ambitious climate change action strategy at the City of Toronto. We update it every couple of years. It's called Transform TO, and it sets our ambitious targets in the various emission sectors that we have that we need to pay attention to. So buildings, transportation, and waste being the big ones. And in terms of new construction, we have the framework we administer through something called the Toronto Green Standard, which sets out performance measures and requirements for new construction only. So for large buildings or for small buildings, Part 9. And we have our target to achieve net zero new construction for any of our city facilities that we build ourselves in place since 2022. And that's in part because we have declared a climate emergency in the City of Toronto, as many other municipalities across the country have done so for important reasons. And we recognize that it's not business as usual, that we do have to take aggressive actions. And in the case of the City of Toronto, we actually have set a net zero citywide target by 2040. And we do monitor and track our progress towards meeting that goal. And we have to, as shown on this graph here, and the red dot was in 2020. We were doing pretty well, and there are a variety of reasons for that in terms of managing our GHG emissions, some related to the pandemic and the closing of coal-fired plants. But in all of those sectors that we talked about, we really have to take a deep dive to try to achieve that 2040 net zero citywide target by 2040, 2050. So the TGS is part of how we achieve that in new construction. And we do have a sort of a pathway out to, it was originally 2030 and has been advanced to 2028 to get to very low emissions new construction. And so what we do with the standards is we increase the requirements every 4 years. So we, use a tiered system where tier 1 is mandatory, and we administer that through our planning approvals process. And tier 2 and higher is voluntary, though, for the private sector. So we introduce higher targets in those higher tiers, and then we gradually bring them into tier 2 and make them mandatory when we feel through study and consultation that the industry is ready and able to do so. So the standard has been in place since 2010, for any who don't know, and we're on our version 4 now in 2022, and then starting to look at what version 5 might look like. The market transformation aspect of the TGS comes through those tiers. So in the voluntary tiers, we actually offer a significant financial incentive too that helps certain developments to get built at those higher levels and set the precedents out there, start to impact the marketplace, even the supply chain, before we bring these things in as mandatory. So since 2010, we've had over 3,000 developments apply the Toronto Green Standard, and it does have performance requirements in all different categories, not just energy, but we're talking about energy and emissions mainly today. We've had 155 projects target high performance, so the voluntary levels. We have over 15 city facilities targeting net zero in design or in construction. And so we continue, our progress in the right direction, I think. And back in 2016 was when we started an advanced study to look at Part 3 buildings in particular and how we could move forward our energy efficiency requirements. We looked at different jurisdictions around the globe. It was called the Zero Emissions Building Framework. It had a heavy level of consultation involved with the building industry. And we decided to shift away from a percentage improvement over a reference building standard for energy efficiency and move toward absolute performance targets in the Part 3 building sector. So these are the requirements that we've had in place for Part 9 and Part 3, the tiered set of standards, a TUI, a TEDI, and a GHGI. So a greenhouse gas intensity target, that's what the GHGI is, that was a really important piece to add, as well as this absolute type of target that measures energy use by floor area, by GFA, instead of just asking for a percentage improvement. And these requirements, they're targets, they're cap targets, they're set out in the standards by tier, as I mentioned, but they're implemented through the submission of a design stage energy modeling report or an as constructed stage energy modeling report. but the standard sets out these 3 measures, and the idea is to reduce energy loads, improve efficiencies and thermal performance, and then force a fuel switch through the implementation of the GHGI. Now, of course, that just deals with operational emissions. So in 2022, when we advanced TGS version 4, it did focus a lot on climate change in general, mitigation and adaptation in general, and we did introduce embodied material emissions targets, but without numbers. So no, actually, I shouldn't say targets, but the process. So we introduced the requirement to do a life cycle analysis at that time, but we didn't include any numbers or targets. And the reason that we tried to introduce that was because we recognize that how important embodied emissions are, that to get toward that kind of aggressive action that we're talking about, that we have to start to deal with material emissions and not just with operational emissions, as typical codes and standards do. That the upfront emissions from the manufacturing stage right to the construction of the building, like starting at the construction site, and the transportation in between account for a significant amount of life cycle emissions. And so we're starting to look at the life cycle emissions of buildings as opposed to just what happens when they're operating. And as we get more aggressive on those operational emissions targets, so then embodied carbon takes a more significant portion of the total emissions of the building. And so that's another important factor that we've been considering, and the reason why we need to move on and advance into addressing embodied carbon from materials. And of course, the global emissions aspect too, where I think this might even be low, that at least 11% of emissions are coming from building materials and construction stage. So in terms of reducing embodied carbon, the approach that we took then was to go into study, which is usually what we do. We're looking at advancing something new within the Toronto Green Standard. We had a study undertaken that was funded by the Atmospheric Fund. It started in, I think, 2021. And it was for all Ontario municipalities, not just the City of Toronto, but we were kind of the guinea pig, I guess you could say. And that study was led by Mantle Developments and with support from the HAF Studio, which is associated with the University of Toronto. And that one, the regulating embodied emissions of buildings, Part 3 buildings, that policy primer, that was for mainly Part 3 buildings. And at the same time, there was another study going on that was led by Chris Maywood and Builders for Climate Action that focused on the low-rise Part 9 wood frame construction. And together, those two studies looked at basically educating all of us as municipalities on what is embodied carbon, why is it important, what are the main emission sources, how is an LCA done, but even more importantly, could we set some benchmarks or targets and apply them within our standards? We did have quite a bit of consultation and workshopping that went on through that study too. That was a real part of the education aspect of it. But we also had an advisory committee that had kind of a wide variety of stakeholders, from manufacturing or the building industry. And the workshops that I mentioned too, some of them are still on YouTube, I believe, through Builders for Climate Action, so they can be listened to still. They were recorded. The benchmarks themselves, though, so in the case of the Part 9, there was a large group of buildings that was involved in that study led by Chris Megwood. Over 500 buildings were looked at together to set targets. And within the Part 3 buildings, a much smaller subset, 41 total buildings in Part 3. But within that, it was a high level of detail. So really breaking those LCAs down into parts using tree maps, for example, looking at where the major emission sources were coming from and really trying to understand that. And from that study, we were able to set, where the cap might be set within policies and standards, for an initial step, a first step. So that's what you see in red. So being fairly liberal and flexible with setting an embodied carbon target. Sorry, before Zach goes, so what we did though in Toronto was we set our targets a little higher than what you see in the red, because we're able to do that within the voluntary level standards. And then we're looking at a trajectory out to 2028 and what our carbon caps would be. So with that, I'll pass it over to Zach, our partner on implementation.
Thanks, Lisa. So yeah, to get into what the caps actually are and we're set at. So we went to council with those reports, and council adopted the first embodied carbon caps in North America. And so to get into what the caps actually are, so we have mandatory caps for city-owned buildings and a voluntary tier 2 cap for private mid to high-rise and non-residential developments. And those two caps are the same. And they are 350 kilograms of CO2 per meter squared for residential and commercial developments, and 400 kilograms of CO2 per meter squared for other building types. And that is for life cycle stages A1 to A5, so just upfront. And then we have another voluntary tier 2 cap for low-rise residential Part 9 townhouses. And that is 250 kilograms of CO2 per meter squared. And that's just for life cycle stages A1 to A3. And lastly, we have another voluntary cap for tier 3 as part of the Toronto Green Standard, as well as a high performance cap for city-owned buildings. And those caps are 250 kilograms of CO2 per meter squared for residential and commercial, and 275 for other building types. And then again, for life cycle stages A1 to A5. Next slide, please, Lisa. So to kind of explain compliance and methodology and verification of compliance with these caps, applicants are required to conduct a materials emissions assessment that accounts for the permanent structural and envelope elements of their buildings. And at the site plan application stage, we are requiring a design stage LCA to confirm compliance. And then when it comes to the methodology of the LCAs and the materials emissions assessment, we are guiding towards a CAGBC Zero Carbon Building Standard version 3 or later, and for the submission of their report template as well. Now, we do veer slightly from CAGBC when it comes to the inclusion of underground parking. We do require the inclusion of the underground parking GFA in the denominator of the intensity factor. And that's in line with the NRC. So that's the only difference between the CAGBC methodology and what we are requiring. And then lastly, when it comes to verification, we require an as constructed LCA to be provided and verified by a third-party verifier once the building is constructed. And again, we are only accounting for life cycle stages A1 to A5 at the moment. So that's everything from raw material extraction to construction. Next slide, please, Lisa. So it has only been a year since the requirements came into effect. And then that might seem like a long time, but the city doesn't build too much. So we haven't really gotten any city buildings that have come in that are required to meet the caps. And that goes for tier 2 voluntary private buildings as well. But we do have a couple of case studies where LCAs were built into the tender documents. So we required an LCA for 2 of our buildings just to see where the buildings are at. They weren't subject to the caps. So the first building is a paramedic station at 300 Progress Avenue. They carried out an LCA for life cycle stages A1 to A5 and found that they were hitting 296 kilograms CO2 per meter squared. And then they also did a cradle to grave analysis and found that they were hitting 380 kilograms of CO2 per meter squared there. And what they did to get there was use low carbon concrete. I think they were using EcoPact, and then they used lower impact XPS insulation and lower impact concrete sealant. And overall, they avoided about 800 tons of CO2 compared to conventional design. Next slide, please. So next, the next sort of case study here is the Mount Dennis Child Care Center. This is the city's first net zero emissions building when it comes to operational emissions, of course. So they also carried on an LCA based on construction drawings, and they found that they were hitting 220 kilograms of CO2 per meter squared. And they did that using measures such as cellulose insulation for the walls above grade and the roof. And they also used timber decks and wood beams. Thank you. So just some anticipated outcomes of our caps. Like Lisa mentioned before, the Toronto Green Standard is a market transformation tool, but when we're talking specifically about embodied carbon and the transformation happening there, we expect more APDs to become available as more of these LCAs become required and completed as time goes on. We expect increased professional expertise, whether it comes to carrying out LCAs or building design optimization. And then we also expect product availability, like low carbon product and material availability to increase, as they'll be a key factor in order to comply with our caps. And then, so as the TGS has set out historically, requirements get more stringent over time. So right now, public buildings are not required to, or private buildings are not required to hit our embodied carbon caps, and only city buildings are. But if the trajectory goes as expected with the Toronto Green Standard, you can definitely expect that there will be mandatory caps that will come into effect in the future. So that would greatly reduce embodied carbon compared to what we are doing now. And then we expect other jurisdictions to follow suit. Like I said, we are the first jurisdiction in North America to have embodied carbon caps on buildings. And historically, the TGS has seen replication with other jurisdictions in the GTA, such as Whitby, Vaughan, Mississauga. So we expect those other jurisdictions to follow suit and come up with some embodied carbon caps themselves to further reduce embodied carbon, not only in the GTA and Toronto, but perhaps Canada as well. Next slide, please. And this is just an extra bit of information. The city is currently carrying out a phase 2 embodied carbon study with Half Design and Mantle, the same consultants that we are working with on the benchmarking studies. And so the idea of this toolkit is to really provide Ontario municipalities with strategies to start really looking at embodied carbon and looking at ways to reduce embodied carbon emissions. And that is through 3 main areas. The first is urban design, the second is through procurement, and the last is through circularity. So yeah, you guys can definitely, we'll keep you updated on this. As part of this project, there will be a toolkit that will be able to be shared, as well as some training sessions for stakeholders. So if you're interested, please reach out and we'll be happy to include you in those initiatives going forward.
Wonderful. Can you hear me? Okay, there we go. Wonderful. Thank you so much, City of Toronto team. That was fantastic. I know I wrote down a bunch of questions. I'm seeing questions up in the chat. We will hold off on questions until the very end of the presentation. So I'm going to pass it on to Charles and Neil to present the second award-winning project.
Great, thanks, Dana, and hello, everyone. And please briefly give us a moment here. We go through the most anxious moment of the day, trying to share the right window and the right screen. Almost there. So great. And thank you again to Zaina and the CLF team. We're truly grateful to be able to present this project here today, and great to share the story. Thanks to all for attending. And we'll begin by giving some credit to our clients, Government of Canada and Public Services Procurement Canada and BGIS, who certainly brought a lot of leadership and ambition to this project, and we're very proud to tell this story today. So we will share with you a brief case study of 25 St. Clair Avenue East. This is a deep green retrofit project taking a 1950s era office building and retrofitting it comprehensively for cutting edge, zero carbon performance, maintaining almost completely the existing concrete and steel structure to substantially retain embodied carbon at construction and delivering a great, modern, healthy workplace. And very grateful to CLF for recognizing the project for an award in the major retrofit category, and very happy to tell the story today. Just first, a little bit of who we are. Myself, I'm Charles Marshall, engineer and partner with Dialogue in our Toronto studio, chair of the Toronto studio, and co-lead, have the great pleasure of co-leading our sustainability and building performance practice here at Dialogue. And I have the great pleasure of co-presenting today with Neil Babishi, who's an associate here in our Toronto studio and our national technical lead in our building performance team. And we'll start just with a brief moment of speaking to values. One of the reasons we're so enthusiastic to work on this project is the alignment between Public Services Procurement Canada and their vision and us here at Dialogue. But we are passionate about design. We believe it can and should meaningfully improve the well-being of our communities and the environment we all share. And we truly believe that deep retrofit projects like this are a great way to reinvigorate and regenerate cities while also delivering substantial carbon emissions reduction, which is a very important thing. Our presentation today will be in 3 parts. We'll give you a little bit of background of the project, so context for understanding some of the info to follow. We'll talk a little bit about embodied carbon, the approach that the project took, and some of the results we were able to achieve. And then I will pass to Neil, and he can lead us through our approach to energy performance or low operating carbon. So just a little bit of background about the project. I did mention it's a fairly substantial retrofit project to a building right in, I was going to say downtown Toronto. Really, this is sort of midtown Toronto. So right at the intersection of Yonge and St. Clair. When contemplating a deep retrofit project, which is a really fun thing to do, 2 key considerations are location and connection to transit. And for that reason, we believe this project was immediately a really great candidate, being right at the intersection of the new St. Clair West subway or LRT line, the Yonge Line subway, connected to bicycle infrastructure. And although it's not highlighted on this chart, you can see on the right-hand side connected to the Ravine network here in Toronto. So a great location for an office building and a great candidate for a comprehensive retrofit. This is a bit of a misnomer. We say existing building. It was actually once upon a time existing buildings built 5 years apart. And then this is the beauty of a history of cities sort of woven together over time and even more so through this project. But 2 10-story office buildings plus parking plus penthouse, originally constructed in 1954 and 1959. One primarily a traditional concrete structure, the other one hybrid concrete and steel structure. A fairly substantial building with a big foreplate of just over 42,000 square meters of gross floor area, so pretty big project. And a tight site, only about 4,200 square meter of site area. You can do the math for a 10-story building, but really not a lot of space, which affects the project in many ways, particularly construction, logistics, and what you can pull off in a very dense urban environment. So lots of fun doing these projects. They are hairy, but all the more adds meaning to the impact. We'll give kudos again to our client at Public Services and Procurement Canada. They were very clear in identifying this project as a potential flagship project for innovation, for decarbonization, for energy efficiency, and for zero carbon performance. That was their approach almost from day one, and really sent clear signals to the design and construction team that was the mission. But I would say even more important than that is the project objective to deliver a modern, healthy workplace that supports occupant well-being, inclusivity, and active transportation. We can talk about these projects like they're an object or like they're a box that uses energy and carbon and so on. But most importantly, this building is a workplace for up to 2,000 Government of Canada employees in various departments and aims to be a very progressive and healthy one. When we talk about objectives, it was set pretty early on that there should be a very healthy target for operating carbon reduction and energy efficiency. The benchmark there was to achieve over 80% reduction from pre-retrofit to post-retrofit conditions from an operating carbon perspective. A pretty wide approach to demonstrating value and achievements through certifications. So this project is a LEED Gold candidate. We're just in the midst of advancing certification there. A WELL Silver certification candidate. I'm very conscious that, that the City of Toronto is on the call today. We are also a Toronto Green Standard Tier 2 candidate, and like to think that process is going quite well. We're in the final stages of verification there. And then, as we said, way back in 2017, when we kicked off this project, we were one of, I believe, about 16 pilot projects for version 1 of the Canada Green Building Council's zero carbon building standard. Obviously up to version 3 now, and it's been quite the journey. This project was zero carbon design certified a couple of years ago, and there is the intention to proceed with that zero carbon performance standard. So really, to sum it all up, deliver a great, healthy, modern office building that performs just like new, and substantial carbon reductions while targeting a balanced and holistic approach to sustainable design and office retrofit capacity. And here's a sneak preview of the result. Project photos coming soon. Actually, those are happening this month. But so we're digging out a rendering here. And I don't want to steal too much of Neil's thunder, but I would definitely say from a modeled and designed perspective, mission achieved some pretty impressive numbers from an operating perspective. Ultra low EUI, substantial energy savings, and met the project objective for over 85% operating GHG savings. So the building just opened this fall, and we're just beginning a comprehensive measurement and verification program to determine how we're targeting towards these targets in actual operations. And a few photos to show you the inside. Like we said, what's mostly important here is creating that great environment to work in a healthy, modern environment for Government of Canada occupants. So with that, we'll get to the carbon and start talking about the embodied carbon of construction. Without a doubt, the main feature of the show here is all of the effort and coordination that goes into reusing almost completely the structure of the two 1950s era office buildings. So as we said, not an easy thing to do. Lots of tough decisions here, lots of investigation, lots of response to site conditions. Definitely takes a level of ambition from a project team, but we definitely think the carrot is worth it when it comes to retaining all that existing concrete and steel. It's easy to say they don't build them like they used to, but the truth is a lot of these old office buildings have a lot of service life remaining and quite good bones, so to speak. So a lot of work went into understanding the existing structure and being able to work with that. A lot of work went into taking a 1950s era building and upgrading it so it could truly be a first-rate workplace and modern environment. But really think this is really key if we think about meeting our goals for economic growth and the future of cities, while also meeting our carbon goals. The reuse of building fabric is a key part of that strategy. I don't think I need to convince this crowd about that. And then on the left-hand side, what you see there is kind of a cheeky photo. This is the moment where what was 25 St. Clair becomes 55 St. Clair, and you can see the transition there from the concrete structure to the steel structure. Kind of a cool thing that one does not see very often. And let's put some numbers to that. On the left-hand side, you'll see a breakdown of our life cycle assessment we conducted for the project. The scope of the LCA included foundations, structure, and enclosure. It excluded MEP and interior materials, as was the convention when we were designing this project, and I would say is still the convention. Lots of discussion about that. So you could do the math here, but about 75% of embodied carbon of the structure and enclosure is in fact the structure. So that is roughly the portion saved by maintaining that existing building and making this a retrofit project rather than a new build. And the impacts there are substantial. We estimate, or we calculate, about 7,700 plus tons of CO2 equivalent saved by maintaining that existing structure. So definitely a project type we are very excited about, and definitely an objective we're quite happy that this project achieved. As you break down a little bit more of that LCA, you can see a few key takeaways here, including that about 91% of the embodied emissions calculated by the LCA are upfront carbon. So just reinforces our understanding of the importance of making those right decisions. Obviously, this is a retrofit context, but generally understood that optimizing structure and the right materials choices and so on are very key. Knowing the importance of that upfront carbon, and then sort of interestingly, following on the previous presentation from City of Toronto, we did calculate immediately our kilograms per CO2 equivalent per square meter or embodied carbon density or intensity, and found it to be about 270 kilograms CO2 per square meter. So on the lower side, I would say for what we're seeing for office buildings, but definitely a good value for us to have. Certainly as we went through our own journey the past 5 years or so working on this project, it was good to have that benchmark for our own portfolio. And these are the journeys you go on as you sort of innovate. Back when we started this design, we did not have the benchmark study from City of Toronto, although we're very grateful to have it now. We did benchmark at that time and sort of found ourselves to be in about the 25th percentile for office buildings based on the slightly older CLF benchmarking study. So again, the number looked a little bit lower to us, but was statistically right in line. And sort of similar story when we later compared to the City of Toronto data. So all of this actually went into our CAGBC zero carbon certification package. Those of you familiar with the zero carbon program, you'll know sort of the workbook and all the material that goes into there, and went through that process of verification through Canada Green Building Council, which was fairly rewarding to help us confirm. And then later on, because you do these things as you sort of read the white papers and so on that are coming out, we decided, how about we harmonize? And back in 2018, we were using the Athena tool quite a bit for doing our LCAs. Over time, I'd say our practice has evolved a little bit. Primarily, we're gravitating towards one-click LCA right now. We had takeoffs and we had obviously good knowledge of the building, so we went ahead and redid that and did a bit of a comparison. I know there are some other studies out there that are comparing LCAs against each other and sort of harmonizing. And what we found was this more or less confirmed that we felt we were in a really good margin of error, so to speak, similar benchmarking result for that embodied carbon intensity, but just different enough that we felt like this was a good, useful exercise to compare those tools. So yeah, on the embodied carbon journey, a project we're quite proud of. We are quite happy to do more of these deep green retrofit projects. Frankly, we think the planet needs them, and glad to see the impacts of that. Of course, as we take on these projects now, we are looking a lot more at the other 25%. I would say there's a lot more material information available these days, EPDs, product-specific EPDs, and so on for insulation, glazing, roofing materials, and so on. And although we love saving that 75% from a building reuse project, the other 25% remains vital. So definitely good lessons learned as we approach future projects. And with that, I will pass to Neil to talk about the other half of the story, operating carbon and energy efficiency. So on to you, Neil. I'm just going to check, Neil. I'm not hearing you. I'm going to see if you need to find the mute button there.
Yeah, sorry, I think I had some issues there with permission. Hope everyone can hear me okay now.
You're on. Yeah, we hear you loud and clear. Thanks, Neil.
All right, perfect. Thanks, Charles. Okay, yeah, so as Charles mentioned, I'm going to switch gears a little bit here and talk about operating carbon and our strategy to getting to net zero emissions there. Just west. Yep. All right. So really kind of 4 key areas of focus, and not unlike any other high performance building we deliver here. And really started off with understanding the internal gains of the building. And so that really refers to all of the plug and process loads that influence the building's overall energy use. And so that really required us to work quite collaboratively with BGIS, the facilities manager, PSPC, as well as the tenants, and really get a really good understanding of what kind of equipment is going to be used in the building, right down to doing detailed plug load questionnaires to understand how many computers and monitors will be used, IT room equipment, etc. And that really helps us understand the potential to harness waste heat within the building and recycle it to lower heating loads. And then very quickly, we sort of focused our attention into developing a high performance building envelope solution, and really focusing on passive design measures to bring our heating and cooling loads down to a very low level before we sort of move into the more active mechanical interventions. That primarily focused around optimizing our air strategy for a more efficient way of delivering heating and cooling within the building, and again, really maximizing the potential for energy recovery. And finally, all of that ultimately led to a state where we had the ability, and all the load reduction measures really enabled us to implement a high performance all electric energy system that was primarily driven through a geothermal system, and we'll talk about that in a moment here as well. So next slide. So just a bit of a snapshot on what the pre-retrofit envelope condition looked like. So the opaque wall assemblies were almost entirely uninsulated masonry, so about R3 in terms of thermal performance. And the new section of the building did have some spandrel with backpan insulation. Again, as we know, it's not the most thermally performing. And most of the windows were generally double glazed, air filled, but again, no thermal breaks, no low E coatings, and somewhat on the lower end of the spectrum as far as thermal performance is concerned. And so in terms of the evolution of the facade concept, there was a real opportunity to reimagine the building facade that faces St. Clair Avenue and Yonge Street. This was one of the few facades that was not surrounded by tall buildings, so we had some good amount of solar access, and an idea quickly emerged of having this stepped and highly transparent curtain wall section to take advantage of the daylighting opportunity. And that was then paired with a key design move of incorporating a staircase that cuts diagonally across the building, and that really was meant to promote a more active and healthy form of movement within the building. And so the other architectural idea there was more evocative of a net zero transition, and sort of emblematic of the government of Canada's transition to net zero. So just kind of reiterating some of the key performance characteristics. So, very low window to wall ratio of just about 23%, a very high performing opaque wall assembly, effective R28, including the impact of thermal bridging. Triple glazed curtain wall systems with thermally broken flaming, and we also conducted in whole building air leakage tests to verify the performance of the air barrier. And all in all, we landed at a model TEDI value of just below 15 kilowatt hours per square meter. So in terms of the mechanical system solutions, we sort of entirely reimagined this. So dedicated outdoor air systems in lieu of your conventional variable air volume systems with reheat. So highly efficient, equipped with very efficient enthalpy wheels to recover heating energy. And really sort of the secret sauce here was the geothermal system. So this consisted of heat pump chillers. So that would enable us to recycle heat within the building as well as exchange heat between the building and the ground. So in many ways, it really functioned as a seasonal thermal battery, and allowed us to provide heating and cooling at a very high coefficient of performance. And finally, we did have electric boilers and water-cooled chillers to provide peaking capacity. But again, the bulk of the heating and cooling was done via the geothermal system. Just to give you a little bit of an idea of what it looks like, drilling a geothermal system underneath an existing building. So just to give you some statistics, about 63 boreholes, 600 foot deep. We did look at a few different options for locating the geofield site, and we sort of landed underneath the existing parkade, again, just given some of the site constraints and limitations. And kind of if you do the math there, it works out to just under 40,000 feet of linear drilling, and that required a lot of innovative techniques and specialized drill rigs. And the end outcome there was a geothermal system that could provide heating for just under 950 kilowatts at a COP of 4.0. So you think about a boiler operating at efficiency of 100%. It's about 4 times more efficient using a geothermal system than it is through a more conventional mean. And sort of switching focus on electrical systems in PV. So of course, high efficiency lighting throughout the building with daylighting and occupancy based controls. And we did manage to put in a rooftop photovoltaic system. So just about 346 kilowatts of DC power, and that's enough to offset about 13% of annual energy use in the building, and also help reduce our peak demands. Okay, and just sharing some energy use data from our energy model. So we landed an energy use intensity, an EUI of just under 63 kilowatt hours per square meter, a TEDI of 15, and a greenhouse gas emissions intensity of 2.5 kilograms of CO2 per square meter. So all very indicative of a very high performing building. And again, if you were to sort of notionally compare this, to the Toronto Green Standard, generally equivalent to the highest tier of the TGS under the new framework. And of course, the greenhouse gas emissions here are just purely a representative of the electricity emissions from the grid, and the government of Canada does intend to offset this at a portfolio level to reach net zero operating carbon. And all in all, an 85% reduction in GHG emissions compared to the pre-retrofit baseline condition. Okay, and as we sort of, change our perspective somewhat from, looking at operating and embodied carbon in singular perspectives and sort of combining it to look at whole life carbon, we did an interesting bit of analysis in terms of, comparing a deep green retrofit scenario for this particular project against a business as usual scenario. So, recognizing that there is a bit of an embodied carbon investment doing a deep green retrofit, primarily around, building envelope and cladding and so on, that does have that initial uptick in carbon emissions compared to, say, a business as usual condition. That was very, very quickly paid off by the reduction in operating carbon. And if you see the math here, it just works out to about a 5-year carbon payback. And when you kind of extrapolate that over a 25-year life cycle, that is equivalent to about 10,000 tons of reduction in GHG emissions that's reduced compared to the baseline condition. And with that, I think we've, yes, that's the last slide. So I guess I'll pass it back to you, Zaina, and we can open it up for some Q&A.
Sounds good. So I have a series of questions that actually came through directly in the chat. What I will do is, okay, I see the first one is somewhat answered by Lisa. There was a question in there about a comment and a question. Great to see that TO is pushing for leadership in this space. How do you account for data quality issues that are still inherent in EPDs and LCAs, which challenge the notion of precision inherent in your targets? Lisa, do you want to touch briefly on your answer?
Just to say that we're aware of that issue. I don't think we have a solution to it yet. I think it requires more standardization and across the board, whether it's to do with, EPDs and how they're reported, which EPDs we're using, if we could develop a local set of EPDs, for example, for products and materials in Ontario even. And so I think there are some new tools and approaches that need to be developed, but I'll pass it over to Zach, but it's early days for us looking at LCAs as well. So that'll also be part of it.
Yeah, happy to add on that. So yeah, we definitely realize there are some data gaps when it comes to EPDs. We are being flexible at the moment when it comes to the data being used. Like we would accept industry averages or EPDs for equivalent materials as long as it makes sense and it's justified. That's the way I think we will be dealing with it at the moment. But like Lisa said, this is something we think definitely improve over time. And as it does, we can make our requirements around what data is required more strict.
Yeah, it makes sense. I mean, make use of the information that's available right now. And as it gets more detailed and we can refine our process and get better and better at it. Exactly. I have another question for both Lisa and Charles. It's kind of they're very related. So the first one is whether the City of Toronto has any comments or notes on the variety of the embodied carbon tools that are available, if there's a particular requirement or recommendation, and have examples of OneClick, Athena, Tally, Tangible. How did you navigate that entire area of different embodied carbon tools?
Well, just from the policy perspective, we decided not to specify a specific software, but to allow any of those for the time being, like industry recognized and used software. That would be one way to standardize some of the results we get for sure, but at the same time, we didn't want to specify any, sort of show favorites on one over the other, I guess. Zach, did you have anything you want to add to that?
Yeah, this also may be referring to the tier 2 requirement for low rise, where we do actually do specify using beam or an equivalent tool. I'm not sure, Lisa, like I wasn't a part of that work with Chris Magwood. I'm assuming there was some sort of decision going into that when it came to the Part 9 low-rise buildings.
Yeah, there were only 2 software available for low-rise Part 9 that we specified in the TGS there for low-rise, yeah.
And the question for Charles that I had mentioned earlier is something very similar to that. You had a comparison between Athena and one-click LCA, which was very interesting. What drove your team to try to see what the comparison is, and did that drive your decision to switch to one-click versus Athena?
Yeah, thanks, Tina. Great question. I suppose historically, like if we think back, like we started this design process in 2017. We were mostly in the busy parts of doing LCA in 2018, 2019. And of course, here we are in 2024 talking about the project. Historically, we would use Athena because that was the best understood, most available Canadian tool. And then, there was a moment where one-click LCA and Tally and other tools sort of came to market, and we sort of had to research and pick one. And over time, we've gravitated more towards using the one-click LCA, and our team is trained in that. We're very comfortable with it. We still use Athena for certain cases. We are not habitually comparing softwares, although it's a fun exercise to do. It came up in this case, because others are talking about it. Like there was an interesting Ramboll authored paper a few months ago, just sort of comparing LCAs and say, hey, everyone's doing these. We're 20 years behind where energy modeling is when it comes to a harmonization and developing a community of practice and so on. Let's share info. So we felt it was fairly topical. And because, we take data pretty seriously. And as we said, the number that we calculated for this project, we have not modeled a lot of projects that are 50-year-old structures that are half concrete, half steel. It felt like kind of a unique case, and it was kind of fun to develop, get our bearings there, so to speak. And B, we wanted to feel good about that benchmarked value. We calculated it twice. It went through CAGBC review. We were going in the right direction, but we felt like a little bit more diligence was worthwhile there. So that was our own practice. I don't know how often we'll sort of do that kind of comparison, but it was a valuable exercise to sort of help a little bit of internal learning here.
Yeah, it sounds like it was a very helpful exercise, and it's actually it's becoming more of a common exercise too, as people are diving into getting into LCAs and adding more details and layers to their LCAs. They're trying to evaluate different tools, and there are actually new tools popping up in the market. I know that that evaluation is kind of challenging, and it's something I think every organization kind of has to go through. So good luck to City of Toronto trying to get some consistency in the future as well. So the next question is actually for Neil. Are there tipping points on this project between operational savings versus embodied carbon in regards to building envelope?
Yeah, no, that's a great question. So, obviously, as Charles mentioned, we did all this analysis and investigation, back in, 2018, 2019. So at different times in terms of our understanding of embodied carbon and so that optimization. But, definitely the sort of intent here was to, drive towards a high performing building enclosure, and more so again to sort of enable that interplay between envelope and mechanical. So one of the key features of the building is because we were able to get our envelope so high performing, we were able to really simplify our mechanical systems and move away from perimeter-based heating systems entirely. So really part of the approach there was to bring our loads down to a level that we can use things like low temperature heating systems that are coupled with with heat pumps and so on. So definitely I'm sure there is an optimization and so that sweet spot between operating and embodied carbon, but here the approach was really just getting to that ultra low performance as far as the envelope is concerned.
Yeah,
Okay.
and that's if I may, that's another conversation where the needle seems to be moving very quickly. Like this project was not designed that long ago, and as Neil says, there was a very heavy focus on energy efficiency and operating carbon reduction. And we did an LCA, and we were talking about embodied carbon. I would say just in the past year, very quickly, we've begun to inspect on most projects, right? Like, are we really adding that 7th and 8th inch of insulation? And are we really doing triple pane glazing on this project? And you know, not to say we've figured out exactly what the silver bullets are, we have a hardline stance for or against any one measure, but we really are finding that when we take a look at a whole life carbon lens, a lot of those techniques are sort of falling by the wayside a little bit, or at least being looked at differently. So it's very much an emerging conversation.
Yeah. We've got 2 minutes left and 2 questions. So let's see if we can get a question a minute. So this question's for Zach. You mentioned third-party verification post-construction. Are there approved verifiers, and what is it that you're looking for in this verification?
Yeah, so we're looking for like an LCA that is based on construction drawings. There is a list of third-party verifiers for Tier 2, and they don't only look at the embodied carbon LCAs, they look at operational emissions as well and the rest of the Tier 2 requirements. Off the top of my head, I don't remember who they are at the moment. I think Lisa would. And was there another part to the question?
What is it that you're looking for as part of this verification? What's the purpose of the verification?
Purpose of the verification is to make sure that they're hitting the Tier 2 caps, because it is tied to a development charge refund. And in order to give out that refund, it has to be verified that they are meeting the caps.
Lisa, could you comment on where to find that verification list, or that the third-party verification?
Oh, the pre-qualified verifiers, yeah, they're available on everything's on the Toronto Green Standard website, toronto.ca/green development. So when you go into the standards, you would have to go to the DC refund page to find those listed, but it's MHEQ building, MCW, and who am I missing?
All right.
And somebody.
I can try
Okay.
to send the link.
As long as they know where to go to find it, that it's on the City of Toronto website.
What?
I think that's probably what we needed. One last question to Neil.
Sorry, WSP. That was the other one.
Perfect. What was the whole building air tightness results, and could you speak about this testing process? And that'll be our final question.
Yeah, no, that's a great question. I'll try to be as brief as possible there. So, so we did have a whole building air leakage testing target, and we sort of aligned that with zero carbon building standards. It kind of worked out to about 1.5 liters per square meter at 75 Pascal. In terms of the process, definitely, had to work, we worked very closely with our building envelope consultant, RDH, in terms of defining their tightness testing boundary. It was a little more, a little more complex in this building, given we had, quite a bit of extensive below grade space. So in terms of separating the condition versus the end condition, there was a lot of detail sort of put in there. In terms of the testing results, so don't quote me the exact numbers, but I believe we landed somewhere about 1.8 liters per second per square meter. So a little bit higher than what our testing target was. And of course, for a building of this nature, and there's a lot of complexities involved. And I think we're sort of understanding how our buildings are collectively performing, partly through all the data that's being collected through the TGS as well. But in terms, but really the sort of the main sort of benefit of doing the test was really identifying some areas for improvement. So we did get a very extensive report back from the air leakage from RDH, and that kind of identified a lot of areas of interest that could further be improved, and that was relayed back to the construction manager as well.
Thank you, Neil, and thank you to all our presenters. This was absolutely fantastic. It has been recorded, so we will post it up on our website. And if anybody has any further questions, I hope it's okay. Feel free to reach out to the presenters directly. It seems like you can find them all on LinkedIn. So thank you so much to everybody. Be sure to register and tune in to the part 2 of the winner series, and keep your eyes and ears open for the 2024 awards launch, which we will reveal all the dates during that part 2 presentation on May 7th. So thanks everyone, and enjoy your afternoon. Take care.
Thank you for having us.
Have a good day.